Hello guys, today we're going to talk about earthquakes and volcanoes in the Central America and Caribbean region. For that, I'm going to share some videos, two videos actually with you. Pay attention, based on these videos, you will have to answer some questions orally. This activity, the first activity of today, doesn't worth any point, but it's going to help you for the following activity, okay?
Quiver, glasses rattle. Soon walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly. But where does this mountain-moving force come from? While we may think we're standing on solid ground, the earth beneath us isn't completely stable at all. Our planet's crust is made up of about 12 major tectonic plates that fit together like a giant jigsaw puzzle. These huge slabs of land float on superheated magma and constantly shift, bump, and grind against one another. It's there, along the seams, where earthquakes tend to happen. When friction between the two plates is violent enough, seismic shock waves ripple through the ground, rattling everything that stands on it. The stronger and shallower the quake, the more violent the destruction. The most violent type of earthquake is born in a subduction zone, where one tectonic plate is shoved beneath another. While one plate is forced downward into the mantle, the other juts upward, often violently. This is the type of quake that rocked Nepal in May 2015. And when subduction happens under the ocean, it can create giant, unstoppable waves called tsunamis, like the ones that killed hundreds of thousands in Japan and Indonesia. On average, earthquakes kill about 10,000 people each year. Sometimes numbers are far higher. The quake that hit Haiti in 2010 killed more than 300,000 by some counts, making it one of the deadliest on record. It is estimated that there are 500,000 detectable earthquakes in the world each year. 100,000 of these can be felt, and 100 of them cause damage. That's about 0.1%. The magnitude of an earthquake is measured using the Richter scale, which runs from 0 to 10, 10 being the strongest. Every whole number increase on the scale means 10 times more ground motion change. In recorded history, the world has never experienced a 10 on the Richter scale, but scientists predict an average of at least one major quake of magnitude 8 or higher every year. The fact is, the Earth's crust is restless and always on the move. We can't see earthquakes coming, but we can prepare for them. Engineers are now designing stronger buildings, resilient enough to survive a direct hit. Scientists are crunching data to project the power of future quakes and anticipate when and where they could strike next. Right now, we can only estimate the probability an earthquake will occur, but perhaps one day we will learn to predict them, minimizing their destruction and saving countless lives.
Okay, so this was very interesting. Wait to see the volcanoes one. Okay, here it is.
Into the heart of the earth, they burn. Bottomless cauldrons fueled by an ancient wrath, bubbling and boiling thousands of miles beneath the surface and just waiting to burst through. Volcanoes are scattered across the planet. About 1,500 active volcanoes can be found across the world, though countless others are on the ocean floor. Most volcanoes, whether on land or underwater, are located where tectonic plates meet. In fact, the Ring of Fire, a path that traces the boundaries between several tectonic plates around the Pacific Ocean, contains about 75% of the planet's volcanoes. There are several types of volcanoes, primarily classified by shape and size. Major types include stratovolcanoes, which often appear as tall, steep mountains; shield volcanoes, which are flatter and dome-shaped; calderas, which are large depressions in the ground, and mid-ocean ridges, which are underwater chains of volcanic mountains. No matter their shape or size, all volcanoes emit gas and molten rock. The journey of these emissions begins deep underground in the Earth's core. The core, which can burn as hot as the surface of the sun, transfers its heat to the surrounding rocky mantle. In doing so, the heat melts some of the rock. This molten rock, or magma, is lighter than the surrounding solid rock layer, so it rises through the mantle. The magma then escapes through vents in the Earth's crust, causing volcanic eruptions. Now above ground, this magma is referred to as lava, and it can reach temperatures of over 2,000 degrees Fahrenheit. In addition to lava, volcanoes may erupt with searing hot gas formed in the mantle. In a phenomenon called pyroclastic flow, this gas, combined with hot ash, can race down the sides of a volcano as fast as 100 miles per hour, burning everything in its path. To measure and classify eruptions, scientists developed the Volcanic Explosivity Index, or VEI. It considers various factors, such as the volume of lava, gas, and other emissions from the volcano, along with the height of the eruption cloud above the volcano's summit. The VEI scale begins at 0. Each successive measurement increases logarithmically, meaning that each magnitude is 10 times more powerful than the one before it. The VEI scale does not have an upper limit, but the most catastrophic eruptions measured thus far are categorized as VEI 8. These eruptions occurred thousands and millions of years ago. The most destructive volcanic eruption ever witnessed occurred in Indonesia in 1815. Mount Tambora, a large stratovolcano, erupted with a VEI measurement of 7. The blast caused earthquakes, tsunamis, and pyroclastic flows that decimated the land and took tens of thousands of Indonesian lives. The eruption even destroyed the top of Mount Tambora itself, turning the 13,000-foot tall mountain into a 3,640-foot deep caldera. While volcanoes are some of the most destructive forces of nature, they have also helped make life on Earth possible. Volcanic ash provides nutrients to nearby soil, making the land fertile. And lava, when it cools, hardens into rock and creates new landforms. With heat from the heart of the Earth, volcanoes have helped terraform the planet, making it the rich, dynamic landscape we see today.
Okay. Let's continue then. As I told you a few moments ago, you are going to practice some questions. You're going to practice answering some questions. Here are the questions. If you couldn't connect with me during the class or the session, pay attention to this. Activity number 1, session 3, week 1. And here are the questions about earthquakes and volcanoes in the region of Central America and the Caribbean. Number 1, list the tectonic plates movements. For this, you have to remember what you learned in Unit 1, but you can also check your book. You can find this information on pages from 36 to 41. Number 2, what is the subduction movement? Number 3, what is a tsunami? Number 4, name the layers of Earth. Number 5, what is the definition of volcano? Number 6, how many volcanoes are around the world? And number 7, what is the pyroclastic flow? You can answer these questions using your book, Or if you want to watch again the videos, you will find the information in there too. And here is a beautiful picture of a Guatemalan's volcano. Okay, guys. That's it for this session. I will see you soon. God bless you all. Bye-bye.